don't we give a round of applause for everybody that made this possible? So we would not be here without John Blackhill and everybody else here volunteering. It's really awesome. Really awesome to get folks out here and see so many people out here for a very first time conference, so many familiar faces. But thank you all for coming out to hear me talk on my keynote front. Today I'm talking about morphing to legitimate attack patterns, and this is something that is near and dear to me because I feel like in this industry we're getting better at some of the stuff that we do, and that's a good thing. And so today's talk is really going to be talking about what we're doing good, what we're going to be doing better at, and ultimately let's blow it up a little bit more so that we have to get harder to detect things again. So I'll be releasing a new tool today calling Trevor C2. Trevor forever, never forget Trevor. But we'll talk about that here in just a little bit. But I'm Dave Kennedy. Whatever. I'm not going to go through my intro again or anything. But interesting enough, a couple of fun facts. I was in a rap video recently. That was really weird. I'm not a rap person in any way, shape, or form. More of like a heavy metal and grunge type of person. And if you were to ask young Dave, would he ever be in a rap video? I'd be like, no, there would be no chance of that. But what was interesting about it is I was literally hacking away on a computer. They built this whole like 1980s hacking, and like there's old screen TVs and everything else, and there's like dancers all around me, and there's rap artists rapping behind me, and I'm just hacking into a computer. It was one of the most awkward things I've ever done in my entire life. Like, honestly, I was so uncomfortable that I can't even explain. And it was funny because I started, like, as I'm hacking, like they have the songs playing in the background, they're kind of lip syncing to the songs, and I'm like bobbing my head, they're like, yeah, please stop bobbing your head. I'm like, oh, sorry, and then I start hacking again, but hackers are cool, right? That's the fun part about everything that we're seeing out here, and that's a neat thing. And seeing it represented in the right ways is kind of neat and all that good stuff. But hope you like to talk today. We'll talk a little bit about this. But I'm sure you've been to a lot of talks lately, and over the past probably 10 years, that the world's burning, hackers are winning. There's nothing that we can do to defend against the attackers that are out there. They're always going to be one step ahead of us. They're always going to have awesome 0 days, and they're always going to be compromising everything we're doing. And that's the tonality that we've set. If you look at what we used to do in the pen testing industry, we used to walk into corporations and organizations, and we break into them, steal all their data, and then high-five each other and walk out and give them a 50-page report. Then next year we go do the same thing. And it was just cyclical effect of breaking in and not really sharing with what we're doing. If you look at today, it's changing a lot. The blue team is understanding a lot of the methods that we're using, the techniques that we're using. And a lot of folks in here are a good reason because of that happening, sharing the knowledge of what they're doing, things that stop them as attackers. And it's interesting because the tonality is changing around attackers being able to get into, now the attackers have to get better and better to not get tripped up when it comes to what we're seeing out there. And so I'll say this is false. We're getting better at defense. Defense is something where it just takes one specific thing to trip us up to get detected. Now we have to shift our tactics into a different way to hopefully not get detected. So it's becoming harder for us as attackers, and it's noticeable. It's noticeable for us when we go on assessments, when we go on red teams. It's noticeable when we go into organizations. It's noticeable when we're doing social engineering and phishing. Now, it's not for everybody, right? And not everybody's doing an amazing job. We have a lot of people that still need a lot of help. And there's a lot of people that still have a lot of work to do. But across the board, we're starting to get a lot better out there, and that's a great thing to see. Blue is actually trying to understand red tactics and their techniques and procedures. We hear the TTPs a lot. It's a big word. But it's interesting because you look at the whole purple teaming concept that John and Mick and everybody else, Rob and a lot of other folks in the industry have talked about for years and years and years around how we needed to share what we're doing on red and how blue really had to have a good understanding of what red was doing in order for us to get better. That's actually happening now. Like we actually are starting to understand. We're actually looking at Sub-T's Twitter account when he's breaking things every single day. We're looking at things like that and understanding what attackers are doing. We're understanding different groups and their motives and how they obfuscate code and the methods that they're leveraging. And we're starting to build those detection criteria in. And it's getting a lot better as we're going along. But we have a long, long ways to go. There's a lot of things out there that we're not doing well. There's a lot of things that we can't do. A good example is protection. Protection is one of those things that is very difficult for us in organizations to actually roll out because it impacts the business, right? Is anybody here using the same version of Java across the board? No, right? Protection becomes very difficult for us to have to go and do it. And I can actually solve the security problem right now. I can solve it all right here. I actually have an idea that would literally fix everything that we do in security. Everything. Everything. You have one security person dedicated to every single employee in your organization. You can sit over the shoulder and No, don't click that. Don't click, oh, you clicked it, all right, I gotta get your computer, hang on. I got a computer coming over, and you can like pass to the next person, and you have every 6 or 7 people, you have a reimager. You go back to the person who gets their laptop back, minimum hindrance of performance. That would actually work. We'd actually have a reduction in breaches because we have somebody overshadowing somebody else, making sure we didn't do anything. We don't have that luxury, right? We have to really focus on understanding those and really minimizing what we can and building detection off of that when we can and everything else. I really love this tweet. I've used it before in the past, but it's probably one of my favorite tweets out there. Can everybody still hear me? Is the mic still on? All right, good. This is one of my favorite ones out there, and the fact that it came from Egypt, who's predominantly red, when it comes to building exploits and writing awesome code and breaking into systems. Jeremiah from Whitehead at the time said, it said an adversary just needs to find one vulnerability to win. To do that, they need to just find one system the target didn't know they owned. And yeah, that's true. So, we're always going to have a vulnerability or an exposure or a way for us to break into a computer system that we didn't anticipate, right? That's how this works. We're not going to be 100% secure. We all know that. But what Egypt countered with, and I love this quote, was, counterpoint, once you're on a system, adversary role reverses. Blue only needs to find one indicator of compromise to catch red. And that's where we're currently at. So, you compromise a box, you get around all the protection mechanisms, you get around their artificial intelligence and machine learning and everything else that's out there today that we know does a great job at everything, right? And we look at that and we say, okay, what do we need to do next? Now we're going to start looking at extracting hashes. Well, do we get caught there, or looking at clear text passwords in memory, or grabbing SPNs and curb roasting, or moving laterally to a different system? There's a lot of different parts of the phases of the attack. We start moving to other components that we can get potentially caught up on. And so I really like this because if we're looking at event log 4624 and we're looking for network login type 3, and we're seeing if one machine from one source IP address is moving to another workstation, and that's something that we're looking for, we can snag that, right? And that's a detection pattern that can trip us up as attackers. And it takes a lot of effort for us to get that initial access to that computer. So now we have to burn a whole infrastructure down, go build another one, go attack again, go a different round, hopefully not get detected that way. So there's a lot of effort now that's going into what we have to do from the attack cycle. And so obfuscation is interesting because if you look at a lot of what we're seeing out there and a lot of what's coming out in the research industry, what's going out from groups like Fin7 and others, is that we have a lot of obfuscated code occurring to get around detection criteria. A good example is this. Does this look legit? A little bit maybe. So going and downloading an executable and starting that process, and downloading it from the internet, it's from a PHP site, so totally legit. And it's using exec bypass, no profile. And so if you look at what we do as defenders to actually look at this information, it's easy to spot stuff like this, right? We see that command being run, we're like, hey, that's not good, right? So we know that that's wrong. Just recently, just a couple days ago, Daniel, DBO, works over at FireEye, posted this one. This one's legit. It's using Casey's method for circutil to go and download something from the internet. And what's nice about it is it doesn't actually use PowerShell to go and download from the internet. It uses circutil to go and download from the internet and executes through PowerShell. Again, does this look legit to you? Should you ever see circutil beginning onto the internet in the first place? It's legit, right? It's good. We're good at that. So looking for things that are abnormal is starting to be a thing that we can identify pretty quickly. So obfuscation now is becoming a problem for us as attackers because it's easy to sift out. Now, if we're just relying off our automated tools, we're probably not going to pick stuff up like this, right? But if we're looking for patterns of behavior, like, hey, PowerShell's now beaking out the internet, I would want to know every single time PowerShell ever called out to the internet if I was in my company. I don't care what it is. Just PowerShell calling out to the internet, period. I can baseline my environment and say, oh, hey, that's an Exchange server, and this specific script calls out, and it's going to these specific IP addresses. I can baseline that, right? I can spend my week or my month baselining PowerShell in my environment and then looking for deviations of patterns of behavior. Why is RegSPR32 ever beaking out the internet? Why is MS build going out to a file share? Like, those are all things that we should be looking at from a behavior standpoint to say, hey, these aren't normal in our environment, I should look at these. It doesn't mean that it's malicious, it just means I should look at these. So, and then you take obfuscation on top of it, you can usually within a couple of seconds determine whether or not this is bad or not. Like, it takes me a second to look at this and say, hey, that's not legit, right? It's not downloading something from a Microsoft site or somewhere else. Another good one, probably not legit, right? Using MSHTA in the about parameter to run ActiveX components. Probably not legit, right? Does this look legit to anybody here? You saw that registry entry getting made into your environment in the current version run? Did that look legit to you? Probably not, right? So things that we can look for that are suspicious in nature that have specific patterns that we can detect on. So that's not legit, right? Not legit at all. Such a good movie, though. Such a good movie.
We're still talking about the slide, right?
Yeah. Oh, yeah. Yeah. It's not legit. So being able to find these specific things is different. Now, if you look at current ways that we get code execution on the systems, typically still predominates executables. Like, okay, we enable a macro or we're using DD auto, but what is it typically doing right as it executes? Goes and downloads a binary. All right, you look at TrickBot that's using the DD auto stuff, or Locky or any of those other ones, are going and downloading binaries afterwards. The fact that we're still dealing with unsigned code, binaries, running in our app directories and our user profiles is a mystery to me, right? So if you look at that and just shrink that down, you look at a lot of different points where we're still getting execution. PowerShell still a possibility, other ways, but still predominantly EXEs. If you look at PowerShell exploitation is dying. If you don't know that or not, I mean, we're getting better at detection when it comes to PowerShell. Now, the good news is that no one's moving to PowerShell version 5 yet. At least not a lot of folks. We're not using constrained language mode. We're not using script block logging, all the features that Microsoft has built into it. But Microsoft has a lot of great stuff inside of it that becomes much more difficult for us to get around a lot of techniques. There's a lot of companies out there doing some substantial work around PowerShell detection. Hey, good indication. Why is the length of a PowerShell command greater than 100 or 500 or 1,000 or 2,000? That's probably a good indication that something's amiss. Or hey, why is system.management.automation.dll being loaded into memory when it's not a PowerShell process? Like, those are good things that we can determine and detect very quickly when something's amiss. So PowerShell is becoming one of the most secure programming languages that we actually see out there. People are going to laugh at that. But from where it came from, PowerShell version 2 to where we're at today is completely different. It's a completely different ballgame, and we're going to be dealing with that down in the future. So if you're using PowerShell exploitation, your window of time for exploitation right now is drastically being reduced. And you're already getting caught in a lot of cases. If you're using invoke expression or encoded command or other things like that, you're going to get busted. Like, it's just the way that it works. Now, if your detection criteria is just looking for encoded command, you suck, unfortunately, right? That's not what you want to be working on. Did you know there's like 16 different variations of encoded command? You have -E, you have -EC, you have -EN, you have -ENCO, you have all these different variations. You don't even have to ever call encoded command. You don't even have to ever call invoke expression. You can do all of that directly from using different methods. So PowerShell is becoming a lot more difficult for us to actively go and use because of the things that they built into it, and that's a great thing. It's interesting to see the whole research community around PowerShell focus on it for the past several years and see what Microsoft actually did to make it better. I mean, PowerShell version 2, I remember giving, so my claim to fame, and I still have it, which is great, is I gave the very first ever PowerShell security talk. It's called PowerShell OMFG at DEF CON. And I remember when I went to Microsoft's site, and PowerShell was brand new. The only reason I knew about it, by the way, is I was at Diebold at the time. And one of my guys on my team came over and he's like, hey, Microsoft's coming in. They have this new beta thing that they're looking at introducing into our environment. It's a whole programming language called PowerShell. It's in beta right now, but they're looking at embedding it into their entire infrastructure. I'm like, whoa, that doesn't sound good. I should probably take a look at that. We're going to be exposing that into our environment here in the future. So I went and actually sat through this Microsoft tutorial. The reps came in and demoed what PowerShell was. And so I started looking at it and I'm like, oh, this could be really cool to run like a whole bunch of tools. And that year we released a tool called PowerDump. I thought it was kind of funny, dumping the SAM database in PowerShell, and a bunch of other things around that. But what was interesting, if you went to Microsoft's website, it said at the time, execution restriction policies are a way to prevent unsigned code from executing on the operating system, right? And after our talk, they fixed it by changing it to execution restriction policies are not a method for stopping unsigned code into your environment. So, you look at where PowerShell version 2 is at to where we're at today with constrained language mode and everything else, it's a lot different and becoming a lot harder for us to actively go attack. And for me, do regular users ever need to use PowerShell? No. Right? God, no. Hang on. Yeah, okay. So in our environments, we have users, and we have this awesome thing called app blocker. It keeps going. We have this awesome thing called app blocker in group policy that can literally restrict PowerShell execution to all of our users right now. Like right now, it wouldn't impact anything. It doesn't mean administrators or developers or your accounts are running. It just means regular users. Do any of your regular users need access to PowerShell? No. Do regular users really even need Java, really, or in macros? I guess so. Anyways, that's good. That's why, by the way, that's why macros are still a great exploitation avenue versus DD auto. Everybody's like looking for DD auto now. Like the whole thing is like all the focus now is off of macros, and it's been great. I ran into 6 customers and they were like, "Hey, here's macros." Like, "Hey, we're not looking for DD auto right now." I'm like, "Okay, cool." But look at this, and this is just like something we can do right now to reduce our attack surface that we're not doing, like basic stuff, right? So here's some examples of good prevention. Regular users block from PowerShell, or heavy logging on that, right? So if we're doing some heavy logging on PowerShell, we can use script block logging, which is fantastic. There's some great stuff there. Interesting enough, if you still look at how like Windows Defender and everything else is working, you know, there's a lot of talk about how Windows Defender's come a long way and how it's done a lot of great stuff. The integration into the anti-malware scan interface for AMSI. What's funny is recently an update to Windows Defender started snagging Unicorn, which is a PowerShell injection tool that I wrote. I'm like, oh, that's weird. Like maybe I'm gonna have to spend a lot of time going to rewrite it, you know, to get around it again and figure out why it's getting detected. I figured, hey, maybe it's triggering off of like kernel 32 being loaded within PowerShell or something else, right? And so I started looking at it and I found that I had one damn variable that I forgot to randomize. So what happened when I randomized that variable? No problem, right? That's still where we're at today in those products. It's crazy, right? So that's one piece. Blocking unsent executables or untrusted binaries, at least in user profiles. Like, do your users really need to be running EXEs that aren't code signed in their user profile directories or their app data directories? Does that make any sense? No. Like, that alone is like a huge reduction of attack surface. Disallowing workstation to workstation traffic, like that's the biggest one that I can't recommend enough. Yes. Yes. Now, we're getting a round of applause for that, because workstation to workstation traffic. Why does Bob in sales need to talk to Mary in IT's computer over SMB and RPC? Like, why does that make any sense whatsoever? So block 135.4.5, like don't allow it to anybody. Don't allow it to anybody from workstation to workstation. I understand your servers may need to do SCCM updates or using Shablik or something that needs a remote from your server infrastructure. But workstation to workstation communication should not be happening, ever. Removing capabilities for DNS tunneling and appropriate SSL termination. Is anybody doing SSL termination? Like one-ish, we had a kind of ish. SSL termination to get visibility in SSL, like we're not looking at that yet. Application control, I'm a huge advocate of application control. So why would you ever want WinWord or Excel or Outlook to ever call command.exe or PowerShell.exe or anything like that in the first place? Right? Should you be allowing that as well? Probably not, right? So looking at what normal behavior is for applications and basing those in. Blocking any known execution types that Sub-T comes out with every single week, or day, or hour. Probably just released 2 right now as I'm talking. But blocking specific ways that we're using for code execution. Some examples of good detection. I love ETW with Sysmon. Sysmon, if you're not familiar, it's a free Microsoft tool. You can go and download it. It's from SysInternals. Mark Russinovich's team runs it. It exposes event log tracing. With that, you can do some substantial detection around Mimikatz injection. If you see vaultclient.dll being loaded from non-specific processes, there's ways to evade that, but if you see vaultclient.dll being loaded from non-system specific processes, you can actually detect Mimikatz as it's coming in. Same thing for process injection. You can see process injection occurring through Sysmon. You can do a lot of other things too, like lateral movement. Great thing about this is most folks that have things like Carbon Black already get this, like with parent-child processes and the network communications. But with Sysmon, you can actually monitor specific executables and binaries and see what network connections that they're actually having along with it. So you can pull all that back. And what happens is with Sysmon is it exposes an event viewer ID, and it's just in your event viewer. So you grab those logs, send them back to your Elk instance or your Splunk instance or whatever you're doing for log centralization. And you can see those and start to build detection criteria. So Sysmon's awesome. Deviations to protective controls like RISE, Register 32 spawning network connections. Lateral movement, you can do that through event log 4624. Now, what's the problem with that specific event log? You actually have to pull it all from all of your endpoints, right? Yeah. Which means that our EPS count now goes up. We have to pay Splunk another $1 million for all of our 4624 event IDs, right?
Splunk.
I like Graylog. I'm a big Graylog fan. Length of DNS packets being set, DNS log analysis, east to west traffic, not just north and south. So some stuff that we can do very quickly to get some idea of what's happening out there. So it's actually getting better. Easier for us to trip up and easier to detect attackers. Again, for some, not everybody out there. So if detection's getting better, what do we need to do as attackers to start to get better at that? And so, when you look at what we're talking about, this is where we start talking about legitimate patterns of behavior. We need to get better at what we're doing. If you look back at how we used to hack probably back in 2005, 2006, social engineering wasn't a major aspect of our day-to-day lives. We did a little bit, but it wasn't every day. We actually hacked through websites. We actually found exposures and vulnerabilities. We got a little bit lazy when it came to end users because it was so easy. People would click a link, you get access, and it was like literally, okay, we moved to different systems. And then we started building out our capabilities and getting better with C2 and starting to emulate RFC traffic, and start to do specific things there. So we got lazy. And SE is still pretty easy. It's still easy to get people to click stuff, but it's getting a lot harder, right? So one thing we need to do is continue to be amazing in what we do, and start moving more towards legitimate attack patterns. And that's really where we start focusing on legitimate attack emulation. And Raf's been talking about this for a long time. I remember Raphael Mush from Cobalt Strike. He gave a presentation at SANS. It was probably like 5 or 6 years ago. And he was at the time talking about how we needed to go more towards adversarial simulation and focusing on emulating attackers and focusing on patterns of behavior. At the time, I was like, man, Raph, people still got Apache Tomcat on the external perimeter. I don't think they should be focusing on this yet. But he was right, in the sense that we needed to start getting better at what we're doing, and companies are starting to get better. And he just posted this yesterday. I'm a huge fan of this quote here. Defenses are evolving, and that's a good thing. As blue TTPs gain ground, it's on us to adjust our operations and find ways to challenge these TTPs. This is how both sides get better. And so again, this is just a natural evolution where we're starting to get better detection, and we've never really had this point in time where defenders have gotten better and attackers are starting to have a tough time getting in infrastructure. It's literally been in, hey, we'll phish somebody, we'll go and grab SPNs, or we'll extract the hashes. All the hash values on the local operating system is the same on every other system. Everybody has RPC and SMB and admin shares open, so we can just move from one system to the next until we find a domain, a server admin. We go to the server admin, and there's a domain admin log into that server box. We go to that domain admin, now we have domain admin rights, then we go extract everything else, right? Or we'll fire up responder. They have a 7-character password. You go and crack that password, and we go into that box. It has admin rights. We go and get into that box and move to other systems. It's not like that anymore. It's getting harder for us to go and do those. So our focus, I love this video. I'm not gonna lie, it's gonna sound really weird, but when I'm coding for a long period of time, every once in a while I'll just stop and just watch this for a couple minutes, and it gives me a nice break. Just one more minute, hang on. My favorite. It's hypnotic. It's therapy for your mind. It's the cat and it's so good. Shaq. I love Shaq. So what works still? Well, DNS is still good, but RFC can apply on legitimate protocols and using legitimate applications. So this is where we start getting into emulating user behavior. So a good example of this is, if I compromise a machine, am I going to have it start ripping out to 50 different ports? No. But can I make myself look like I'm browsing a website? Yes. Can I do things that don't exhibit patterns of behavior that would be tripped up by an individual? Like, hey, if my process is going to be going out, I should probably be using Internet Explorer or whatever their known browser choice is, leveraging that as a method to piggyback. So using that for an initial foothold and then start to move and start to exhibit legitimate behavior. Another good example is look at the actual system you're going onto. Most of the time, when we first get into a box, we drop into a shell and we start pillaging. Why not grab a process list and see what's actually running on that box first and figuring out what they have as far as defenses and building our attacks off of that, or seeing what systems we're connecting to and start going after those systems versus going to lateral movement and other systems out there as well. So, this one too is another big one where C# is really becoming, and .NET, is really where a lot of the focus is becoming on, because there's literally no visibility into that whatsoever. You can run MS Build without getting detected. You can run C# code with getting undetected. That's another big feat here. And hi, Casey. I got a slide in there for you. Yeah. If you look at two of my faves, my BFFs that I think are doing the most amazing things in this space. Matthew Graber is one of those, and Casey's another one. If you're not following them, I would recommend putting them down right now and following them. And checking it once a week, because you probably have a new indicator that Russia's using now because of them. It's a good thing. It's a good thing, Casey. It's a good thing. You're doing good stuff. And a good example of taking that and leveraging something like MS Build is we recently released a tool called MPS Payload. And there's two payloads in there. One's a C# payload, the other one's a PowerShell payload. And what you can do with MS Build is you can call remote file shares and have it go and pull down specific code and execute directly into memory, which is great. Specifically with this one, if you're not familiar with MPS on what we call non-PowerShell, Ben 10 came up with a technique where you can call the system management automation.dll and leverage PowerShell fully without ever calling PowerShell.exe or PowerShell_IC.exe. And so with this, you can actually leverage the full functionality of PowerShell without ever calling PowerShell itself. Conversely, if you want to get around things like Silence, you just rename PowerShell.exe to moo.exe and you're all set. So there's a lot of different ways of skinning the cat when it comes to this, but calling in system management automation.dll without ever running PowerShell.exe and not getting detected typically trips up a lot of the EDRs and things like that out there. So a good way of getting around specific patterns. But again, why is msbuild.exe beaking out to the internet? It's probably not a good thing, right? Let's talk a little about Magic Unicorn. So I'm going to show you a demo real quick, and this is one of the new versions of Unicorn. And if you're not familiar with Unicorn, it's just an obfuscation tool for PowerShell. And actually, I think it started with Gates. He was on a test and he couldn't get something to work. So with Unicorn, you have a few different options. You can do HTAs, you can do DDEs, you can use the circuitil method to convert a payload back. You can import your own PowerShell files. You can do macros, and it has a lot of other capabilities built into it. But what's nice about this is, from an obfuscation standpoint, if you're looking for patterns like encoded command invoke expression, you're probably not going to have good detection. So I'm just going to generate the code real quick here. Computer's running slow today, apparently. Here we go. Let me just copy it over here so you can see it easier. Totally legit, right? See that in your environment? It looks normal. I'm sure that's Exchange. But notice what we're doing here. Do we ever call encoded command? No, right? But we are calling encoded command. We use set variable and get variable to piece together a bunch of strings. We chunk up things like GB, so you can't look for get variable. So it's G, tick tick, V, things like that that cause a lot of obfuscation in there, right? So from a PowerShell perspective, this is loading up shellcode directly into memory. Now, a good example of an indication off of this is syswall64. Okay, so it's going to be calling the SQL /Windows /syswall64 /Windows PowerShell /version 1.0 version /PowerShell.exe. There we go, I memorized it. So it's calling that specifically. So if you see syswall64 hitting in your environment, it's probably a good indication something's amiss. But still, I wouldn't just use that as a good indication. The length of this command is a good one, right? This also has network connections as well. It's going out to the internet with the shell. So PowerShell beaconing out to the internet. You should see multiple things on this specific one, but not based off of the, hey, I'm going to look for, G whack whack V. That's not a good detection criteria. You're just kind of focusing on a lot of the specific areas around that cat and mouse game. Interesting enough, there's a lot of other things you can do too. Like a lot of tools will look for base 64 encoded strings. So what you can do is just chunk those up. So it doesn't actually create a full base 64 encoded string. So when you see those, it messes the whole decode function of it up because they usually don't join those together. So again, just ways of messing with the tools. Another good one. Don't go to sleep on me. That's good. Use macros. So most people will look for wscript.shell, PowerShell, command.exe, things like that that would be embedded inside the macro, right? So why not never use any of those? So as you can see here, break those up a little bit. Now when you're writing obfuscation, by the way, the worst part is having to go back and change your code. It sucks. Like, what the hell did I write? And I'd been drinking at that time. So you look at the code and you're like, wow, that's amazing. I don't even know what's happening at this point. So it takes a lot longer, but if you look over here, totes legit, right? Totally looks legit. Again, but not calling encoded command. So this whole encoded thing actually spawned because I think we have some kids in there, so I might not show this, but I went on a long rant on Kaspersky, and I'll just get rid of that one right there. Hide that. I'm going to kill that line here. Hang on. All right, I'll get rid of that. And so, oh, there's still one there too. Sorry. Get rid of that. Anyways, long night of frustration there. So just different ways of obfuscation, right? But those things are easy to spot. So, let's talk a little about Trevor C2. Trevor. Now, interesting enough, some folks didn't react so well to the whole Trevor thing, but to me, you have a dead cockroach that generates $5,000 for Puerto Rican relief fund from the Hackin community. Like, that is the most amazing thing ever, right? That's what this community is. We can use our platforms to do hidden jokes, as anybody does. So here's the CNN one here. I just wanted to show it. It's my favorite.
David Kennedy, a cybersecurity consultant and former employee of the NSA. Gentlemen, it seems that the news conference by the Senate Intelligence Committee was designed to do three things, send three messages. Number one, we're not done yet. Number two, we're still searching for proof of collusion. And number three, the Russians are still coming for us.
David, some of these key swing states like Michigan and Wisconsin were targeted, and these are states that President Trump won by 10,000, 20,000 votes respectively. But also these ads were all over non-swing states, right, like California and other states. I think one of the questions is, does it take collusion to sow chaos?
Well, if you look at what the Russians can do, I mean, they understand our political system. They understand hot button topics. And I was actually discussing this whole thing with my late friend Trevor over milkshake. The fact that we can use a cockroach to have some fun, it's fun. We're hackers, that's what we do. We take a milkshake that you suck through a straw, which is a terrible incident, and we turn it into hurricane relief funds and costumes and embedding it into part of the industry and just having fun with it and laughing at it. So, good on that, and everybody else that's been making it. It's absolutely theirs. And some of you, I understand it's a little old for some folks, but I'm still a kid, and I think it's hilarious every time. I mean, I go home and I'll just start giggling because I think about Trevor. It's epic. I mean, it's awesome. So, what's Trevor C2? So I have a lot of open source projects that I'm currently working on, but honestly, I probably will make it a framework. I will figure it out. But I'll be releasing this today up on GitHub. So via github.com/trustsec/TrevorC2. What it is it emulates a regular user trying to browse a website just as we would. So what ends up happening is the Trevor server portion of it, the server infrastructure, will go and clone any website you want to or import in any website that you want to. So very similar type features to like the social engineer toolkit, right? You go and you clone a website and embeds all the stuff into there and it goes into tags. So what will happen is when it goes to clone the website, you go and you register your DNS names and everything else as usual and point to this site. But when you go to browse the site, it's a legitimate site. The site has all the images, it has everything that you need for it. The site is browsable by a regular user. So as an IR person, I'm going to this site and I look at it and I look at the code, it's going to look good. It's not going to look crazy, malformed. It's going to look like a legitimate site. Built into the site, into the source of the site, spread out through the whole site itself, is C2 stuff. And so it's going to be leveraging that. And so the C2 stuff is actually embedded into the site itself throughout the whole source of the HTML. And it uses a way for command and control. It's all GET requests. There's no posts. We're not exfilling a bunch of data out of posts. And the way that it works and the way that it uses it is that when you go to the site and the client goes to execute, the only thing that the client needs is a query string parameter. And then this is all randomized by the way. It's all configurable in the C2. The query string parameter, the path you want it to go to, and any extension types you want. So what it does is it makes it look like it's loading. When you hit it'll refresh the site, and it'll make it look like it's loading other files in the site, like images. And in those images, the file names themselves are actually the data that's being sent back and piecing it back together. So the C2 is actually based off of it looking like it's a legitimate site being loaded every so often. Random beacon intervals, so it goes between certain time frames. You control it. You can have it done from every 30 seconds to 5 hours for what you want to before it checks in and hits it out. But basically, it makes it look like a user is browsing a website in a legitimate fashion and emulates it. User agent strings, everything. Now, what's great about this is it's so simple to go and build a C2 platform for it that building it in C# is easy. Building it in PowerShell is easy. I just did a proof of concept with Python, but all you really need is simply the ability to go to a website via a browser and have it go to a specific query string parameter and then system commands and then in a while statement. That's basically it. So I have all the examples in there. I'll be releasing a C# and PowerShell module hopefully within the next week or so. I started working on it last night, but then I decided to get into the Trevor costume and get downstairs and drink. So that happened. So I'll hopefully have that done next week. with the C# ones and the PowerShell ones. But right now, there's a good proof of concept example there from the client side. So let's take a look at what it looks like. Crap, I need internet access, 1 second. I need to get an adapter too, actually. I'm not gonna lie. Join the Wi-Fi. We're all friendly here. 1 second. We're good. So let's take a second to pop up. Let me get Trevor's CT ready. Now, if you go to the code, all these things are configurable. So the user agent strings, you know, the pass that you can use, query strings you want to use, you can customize all of those. It's all configurable options. I highly recommend configuring. Now, one thing that I'm not doing currently that I will incorporate is the way that they're chunked up is your command and the data gets sent in a base 64 encoded string. So I'll put AES in there before I commit it. I just haven't had a chance to. So that AES is in base 64 encodes and then chunks it up randomly throughout the images themselves. So it'll still make it look like it's loading that, but it'll chunk it up into a way that doesn't get detected. And you know, there's a stub here if you want to use like specific paths that actually parse the data. It's all really easy. The README walks through pretty much everything. It goes through all that stuff. So what's nice though is in Python you have what's called simple HTTP server and base HTTP server, and you have the ability to hijack the do get and do post commands for everything. So what ends up happening is when you get intercepted with the do get, if it identifies that it's a client, it can put back different data back to that client to do the command and control piece of it. So that's kind of how we handle the instruction sets when it comes to that. So works out really well. Turn this on. All right, we're good. All right, so I run Trevor, and it's just going to clone trustsec.com as an example. Right? It's not a hacker tool unless you got ASCII art, all right? Plain and simple. And so now what I need to do here, let me grab my IP address real quick. So it's 224, actually that's what I got over here. And all I'm going to do is this is just a proof of concept on the Python side. I'm going to double click that. And now we have our shell running. Now if we want to execute any commands, we just type in a command, and it'll task. Connect it back.
Yay, demo.
It'll be fine, don't you worry. I did late night coding changes yesterday, probably didn't test them, so that's probably why. It'll be fine. Try that. Well, it will work, I promise. There it goes. All right, so that's the local one. Here you can see we receive a response back from the client. Now let me try on the other side now. Let me cancel this one. Just make sure I got my IP address right. 37224. Right. Run it again. And it's task. We'll see if that comes back up. Now, it could be the random intervals. I upped the time frames for it as well, so we'll see if it comes back here in a second. What's great about that is the random intervals can go from low to high. So, and it worked up here. Maybe my Windows machine's having issues communicating, but you know, we can do list commands. It's usually pretty quick. Anyways, I failed. It's all right. It works. It works. It works for that. So that's it. Closing. I will have it fixed before I publish it up. But nice job, defenders, for some of you. This means that, probably the entire time that I've been in InfoSec, we haven't been in a position like this before where we actually have to continuously raise our bar. It's not as easy as it was before, and that's a great thing. That's a great thing. That means we're making a difference. It means we're doing things great, and we're getting better. Now, we have a long, long, long ways to go, and we're never perfect, but we're doing an awesome job. So thank you, everybody. Appreciate it.